Our next topic is inverse functions. Before we get into the particulars of what inverse functions are, we're first going to explore the idea of one function canceling out another. That's going to help us define what it means for two functions to be inverse functions of each other. And then we're going to do some examples. The central idea of inverse functions is the idea of two functions canceling each other out. And so since we can think of functions and actions, we can think of that as actions canceling each other out. And the basic idea is you do both actions, and then you end up where you began. So you start with one input, you put it into both actions, and you end up at where you began with the first input. So as an example of inverse actions, you could think of putting on your shoes and taking off your shoes as inverse actions. So for instance, if you start by having your shoes on, then you take off your shoes and then put on your shoes, what happens is you're going to begin and end that process with your shoes on. And if you start with your shoes off and then you put on your shoes and then take off your shoes, again, you're going to begin and end with your shoes off. So the idea is wherever you start, if you do those two actions, then you're going to end up exactly where you started. So here's a more mathematical example. The action of adding 5 to a number can be canceled out by subtracting 5 from a number. So adding 5 and subtracting 5 are canceling out actions. So if you start with a number and you add 5 to it and then you subtract 5, you're going to end up at the exact same number you started with. And this is going to work in either direction. If you started a number, subtract 5 first and then add 5, you're still going to end up at the same number you started with. You're going to have a similar thing happening with multiplying a number by 3 and dividing a number by 3. Those actions cancel each other out as well. And again, the idea is they cancel each other out, and they cancel each other out in either order. If you multiply by 3, then divide by 3, you end up where you started. If you divide by 3, then multiply by 3, you still end up where you start. So the idea of inverse actions, and again, we can think of these as inverse functions. These are actions, functions that cancel each other out. And the notation that we use, if f is one of the functions, then f inverse is going to be the f inverse, is going to be the inverse function that cancels out f. All right, so let's look at an example. So I told you the action of adding 5 is canceled out by the action of subtracting 5. If we want to think of the action of adding 5 as a function, what we're doing is we're taking an input and then adding 5 to that input. So if x is the input, x plus 5 is the output. And then the inverse function is going to be the action of taking your input and subtracting 5. And so then you get f inverse of x is going to be x minus 5. If you want to think of what f of x equals 3x is, that's taking your input and multiplying by 3. So it's the action of multiplying by 3. That gets canceled out by the action of dividing by 3. And so if you take your input and divide by 3, you get f inverse of x equals x over 3. So these are the function versions of the actions that we were thinking about in the last slide. So in general, what we want to do is we want to start with x. We want to do f to get f of x, right? You start with x, you do f to x to get f of x, and then you do f inverse to get back to x. F and f inverse cancel each other out by starting and ending at the same place, namely x. So if you start with x, and then you do f to it to get f of x, now you're going to do f inverse to that to get back to x, and that is taking the composition of the two functions, f inverse of f of x. And again, that should take us back right to where we started. That should be equal to x in order to be an inverse function, in order to cancel it out. Same process works in reverse. If I start with x and do f inverse first, f should cancel out f inverse. So if I start by doing f inverse, then do f to that to get f of f inverse of x, that should take me back where I started, which was x. So this is the type of thinking that leads us to the formal definition of what an inverse function is. So let f and g be functions. We say that g is the inverse of f, or g is equal to f inverse, if both f of g of x equals x and g of f of x equals x. In other words, if we do f and g in either order, we begin and end at the exact same place. So for instance, if I have f of x equals x plus 5 and g of x equals x minus 5, I want to know if g is actually equal to f inverse using the definition. It sure seems intuitively clear that they should be inverses, but let's see how they work with the definition. So first of all, we have to look at f of g of x. Now we're going to have to just do the same thing we used to do with composition of functions. G of x, we know what that is. That's just x minus 5. Now for f, it helps to think of f as an action. And so if you look at f of x equals x plus 5, that says I take my input x and I add 5 to it. So whatever my input is, I add 5 to it. Which means that if my input is x minus 5, I take that input and add 5 to it to get x minus 5 plus 5. The negative 5 and the plus 5 nicely cancel each other out, and I end up with x. So if I do g, then f, I end up with x, which is exactly where I started. Now, if we do g of f of x, it's going to be the same thing, just different functions in different orders. So f of x we know is x plus 5. And if I think of what g of x plus 5 is, g of x equals x minus 5 says that I take my input and subtract 5 from it, which means if my input is x plus 5, I'm going to take that x plus 5, subtract 5 from that. Again, the 5's cancel to give me plain old x. And what that tells me is that indeed f inverse of x is equal to x minus 5. So I started off calling it g of x just so I'm not assuming that it's the inverse function. I check to see it's the inverse function, and then at the end I declare, yes, I was right, it is the inverse function. So let's do the same thing with f of x equals 3x and g of x equals x over 3. Now, if I take f of g of x is x over 3, so I can just put that in. F takes the input, f of x equals 3x takes the input and multiplies it by 3. So if my input is x over 3, my output is going to be 3 times x over 3. The 3's cancel each other out to give me x, which is exactly what we wanted. If I do g of f of x, it's going to be very similar. F of x equals 3x. And g takes my input x and gives me the output of x divided by 3, which means whatever the input is of g, I take that and divide it by 3. Down here, my input is 3x, so I take that 3x and divide by 3. And very conveniently, those 3's cancel and I end up with x. And that means that in this case, f inverse of x is equal to x over 3. All right, so here's a slightly more complicated example. F of x equals 2x plus 3. How do we cancel this? Well, again, let's first start with x. Let's do f to it to get 2x plus 3. And now see what kind of actions that we have to do to get back to x. Because whatever those actions are, we're going to put those actions together. That's going to be our inverse. So how do we get back to x? Well, we're starting at 2x plus 3. First thing we want to do is subtract 3 to get 2x. And then we're going to divide by 2 to get x. Right? So the 2x divided by 2 gives us x. So our inverse function is going to be the action given by subtracting 3 and then dividing by 2. So if my input to my inverse function is x, my output is going to be gotten by subtracting 3 and then dividing by 2. So I'm going to first subtract 3. That gives me x minus 3. Then we're going to divide by 2. And that gives me x minus 3 over 2. Which means that my f inverse of x, at least I believe it to be the case, is x minus 3 over 2. All right, I should check it though, just to make sure. If we do f of f inverse of x, let's see. F inverse of x is equal to x minus 3 over 2. And let's see what f does. What f does is it takes the input, multiplies it by 2, and then adds 3. So it's going to take my input 2x minus 3. It's going to multiply it by 2, and then add 3. Those 2's are going to cancel to give me x minus 3 plus 3. The 3's are also going to cancel to give me x. And so I get f of f inverse of x equals x. I'm very happy. Do it in the opposite direction, similar situation. F of x is equal to 2x plus 3. And let's see, what does f inverse do? Well, what it does is you take your input x, you subtract 3 and divide by 2. So I'm going to take my input, which is now 2x plus 3. I'm going to subtract 3 and divide by 2. The 3's in the numerator cancel to give me 2x over 2, and then the 2's cancel to give me x. And so, indeed, my inverse function is f inverse of x equals x minus 3 over 2. All right, so now I think you're ready to work on the activities. It's called Introduction to Inverse Functions, and it's on the PDF included with this video.